Hello, everybody, and probably good evening for me here in Germany. It's already decently late. I don't know where you are situated on the planet, but yeah, as I said, for me it's already decently late. But no better way to finish an evening than to have a workshop about enterprise IDPs, how to standardize and automate with Humanitec. So let's take a look at what is on the menu today. Here we go. So let's quickly get on the same page first, right? We need to be on the same page. I spend a few minutes on saying why I'm wearing this shirt here, saying Humanitec, and what the context is that we're operating then. Then I'll answer the question why IDPs need a backend, step over the reference architectures, and after you've got all of that content, you will see why an orchestrator is the perfect backend. And I'll round everything up with a demo from score to production. So let's dive right in because time is short. Okay, so about us and also about me. So Humanitec, we serve platform engineers. Nothing could be truer because platform engineers are our core target group. But in essence, we serve companies because we help build platforms, and platforms literally help everybody in a company achieve their goals. So let's see what Humanitec brings to the table. We bring a few products. Those would be a portal and a score, an open source workload specification. We bring the orchestrator and the resource packs, which are a little bit more in the backend domain. We have a very opinionated process, how you get from discovery over an MVP motion, a minimum viable platform build, and a production readiness program up into production scaling. And usually that works out quite well. So we can confidently say that every 3 workdays, a global enterprise is starting a platform engineering journey with Humanitec. Today, I've had a kickoff with a major enterprise here in Germany. That was also nice. Let's see who I'm doing on Friday. So, we serve you from 3 country offices for global coverage. Around 200,000 platform engineers are active in our community. If you've not been there, platformengineering.org. That's a great place to hunt for more content and for communication and collaboration with peers in the art and discipline of platform engineering. And we have close ties to all cloud and on-prem providers and global SIs. Well, so much to what marketing makes me tell you. Let's take a look at the context and how that is actually going to pan out, or how it is describing the problem field that we are in. So usually we start on the bottom end of the pyramid, and well, interesting challenge because I don't know how to move my camera up, but there is a developer hidden under my camera image. And the problems that poor guy is dealing with most of the time is missing self-service, a lot of cognitive load, high wait times, and because all of that, everything is slow, right? On the other side, you have infra and operations people who are drowning in the same mess, essentially, because all of that missing self-service is leading to a ton of ticket ops. Yeah, and because all of those ticket-driven processes rather lead to one-offs, low standardization, insecure configurations, manual reviews, all of that is coming, right? And because everything's so slow, the costs are spiraling out of proportion. So, what are the main value drivers in this situation? Well, who would have guessed from the title of the webinar? It's going to be automation and standardization. But literally on the developer side, to get from the missing self-service to self-service, what you need is automation. And automation to the highest degree, up to the point where you can let somebody else push a button to procure one of your pieces of infrastructure. Basically like a vending machine. Yeah. And on the other side, we have infrastructure platform engineers who care mostly for the standardization, which means they would like to have less invariations of all of the infrastructure so that they do not need to care for every bespoke instance in maintenance efforts and in lifecycle and total cost of ownership, but for probably classes or buckets of infrastructure that can all be handled in the same way. And obviously, all of that leads to the fact that the time to market goes down, the cost goes down, and the innovation rises because things are deployed more frequently and people just have more time to work on innovative topics. Managers tend to be happy about this. Okay, so that is the problem domain. How do we go from here? Let's take a look at, on an abstract level, at the topic of automation, right? This is a real customer example. So workflow was, I need to have a DB of type Postgres for my existing workflow from workload from dev to prod. So dev, staging, prod, 3 instances. Without a platform, that took our customer actually 19 interactions and around 3 weeks to complete. Yeah, that was a high manual effort, a lot of touch points, many people involved, and of course, every time you have such a manual touch point, something can go wrong. What we managed to make out of it was, with a platform, you have 0 interactions, and it takes you 5 minutes. That's about how long it takes for the infrastructure as code modules to actually roll out the needed databases in dev, staging, and prod. Yeah, the risk factor was literally low to non-existing because the whole thing was fully automated, completely standardized, and nothing could go wrong from there anymore. That this is valuable is clear. That's the more obvious part. Let's look at the other side. Standardization. So to demonstrate how standardization is actually influencing the game, let's take a look at all of the Postgres DBs in staging. Yeah, if you look at your own runtime estate and you look at all of your Postgres DBs in staging, there probably might be quite some configurations, like in this example here. Yeah, all of them are bespoke instances. So this is obviously a situation which is not desirable, right? Every time you need to have any kind of intervention on these instances, think about a critical security flaw that needs to be patched, you need to work against each and every of those configurations. And as most probably, these configurations are also scattered across the enterprise, across different source code, different source code repositories, different versioning providers and whatnot. Yeah, it's probably a very tough effort to get them all tackled. What you rather would like to have is something like this, where you have a central resource definition, which is a template from where every of those instances in staging are being baked. That would make a lot of sense, right? There would be 0 chance for configuration drift. And also, obviously, you know exactly how every instance is configured. That would be great. But the question is, in the end, why does that lead to a different question? Oh, wait. Why do IDPs need a backend? And the answer to that one is that if you think about what you've just seen about automation and standardization, then you literally cannot hide that behind any kind of triggered process that has little or low logic. And you cannot hide that behind a one-off process. So you cannot hide that behind a ticketing process, right? It would be very hard to maintain a steady stream of tickets, which actually all reach the same target end state, right? Even if it was fully automated and a self-service button that you just pushed, If it was just generating the instance and then dumping the responsibility for the lifecycle of that resource into your lab, it would over time lead to the same situation as you've seen here for staging. All of the instances would slowly but surely drift away from each other, and there would be no central lever where you could just pick them all up and say, okay, I want to move them all around. And the answer to that is you do not just need a front-end layer for your IDP, which has the shiny button that you can push. You also need a back-end layer for your IDP that has all of the right things in place which are needed to facilitate exactly that. Okay, let's take a look at the design of an IDP which takes this into account. So this time, this is the right slide. So this is one of our reference architectures. You can find them at humanitec.com/reference-architectures. And this is the AWS incarnation. I have taken the liberty to actually go ahead and mark out the front end, which is in a slightly bluish background, from the back end of the platform, which is in a slightly grayish background. So all of those here, they are part of the back end of the platform. And the reason for that is that you actually want to have that bespoke logic, which is able to care for the life cycling of the resources, which is able to care for high automation, which is able to care for all of the cross-cutting concerns like security, compliancy, and legal, which is able to care for all of that rolled into your platform. And the centerpiece in this case, who would have thought, is the Platform Orchestrator. This is the body who facilitates all of the other things coming together. So, but let's quickly take a look at what else is on the picture here and what is important and what not. So first of all, it's the AWS one. There are different ones. Secondly, you can have many resource planes. So it could be a multi-cloud one or a hybrid one. Then there are the planes. They give you general direction where something is happening. Important. Don't want to delete this. You have the boxes, which are for capabilities. Important. You don't want to delete this. And this is like the least common denominator among platforming attempts that we've at Humanitec been helping during our tenure. And you will most probably be able to build a platform that has a lot more boxes. No issues with that. You will most probably not build a platform that has less boxes. So that leaves us with one seemingly not yet mentioned part, and that is the icons. So the icons literally are what provide the capability of the box. So let's take CI pipeline in this case. That would be GitHub Actions here. You can freely replace that, right? If you say my company is a little bit more classical, we still have Jenkins around, then you just replace that with Jenkins, and everything else can stay untouched because it's a reference architecture, no solution architecture. It can still be heavily modified to suit your needs. The good part about those reference architectures also is that they come in an infrastructure or platform as code mode, so completely terraformed, which allows you to stand up the whole thing as you see it here in, I would say, 40 minutes. Yeah, so 40 minutes for the ISC, probably 20 minutes to get all the configuration right, so in about an hour. Okay, so let's answer the question why the orchestrator is the perfect centerpiece for your backend. And the answer lies in its ability to actually solve all of the riddles that I've talked about in the beginning. So let's start with Score. Score is a workload specification. It's open source. So score.dev is where you go and take a look. It's currently being donated to the CNCF. And it is what I would say 98% of developer interactions with our platform, with platforms that are built with the orchestrator, are about. Right? because that's a companion for your workload that you're working on. In this case, we are working on a product service, yeah, and we are asking for the platform for some resources. We want to have a PostgreSDB, an S3 bucket to store some larger things, then go in the database. And we want to have a DNS record because we hate typing IP addresses. All right, so having said all that, we obviously want to pass some configuration back to the application. You can see that with those replacers here, the created databases connection string is passed back to the application, so it comes together. And the interesting thing is this is exactly the abstraction level that developers care about infrastructure, and that's where Score stops. Right? It is not caring for the whole application, so this is just one service. It is not caring for how in detail the infrastructure is configured or maintained or created, because developers literally, please excuse the French, tend to give a shit. Right? They just want to have that database to connect their application to so they can actually solve a business problem, because for them, that's the hard work. Yeah? And this is exactly what Score is making possible here. But just this abstract request is not going to complete this, right? We need to have something on the other side as well. And that is a resource definition. This is a way for infrastructure and operations teams or for platform engineers to set rules how resources of a type should be configured by context. What does that mean? So going back to our example, if the developer had requested a Redis cache, so here, Redis cache is being created. Where is the logic and the intelligence coming from on how to create that thing? From here. It's coming from an IAC model, which is module which is residing in Git and which will actually create an elastic cache. So Amazon's Redis cache as a service offering for me. Yeah. And we have some matching criteria. It says here, if the environment type is production, and that is the context. So usually the pipeline knows where something is going. And that leads to the fact that the orchestrator can also know, yeah, okay, we're going to deploy to production. So let's see how we create a Redis cache for production. Probably not an in container or in cluster container, which could pop any second. Yeah, and by that lose the cache contents, because in production caches tend to be huge and rehydrating them could be a serious impact for the end users. So we want to have the elastic cache. We want to encode all of the logic in infrastructure as code modules, no problem. Yeah, and now the orchestrator knows that a Redis in production is constructed this way. Cool. Because together with the score file, which allows for an abstract ask for infrastructure, this configuration allows for an abstract configuration of the orchestrator, how to do things. Yeah, and all of the intelligence and logic can still be as usually as it was done in the past, most probably, and the applies as well, and encoded in infrastructure as code languages. Okay, let's take a look at what happens from there. The orchestrator is a graph-based backend for a platform, not a pipeline-based backend. So pipeline-based backends or pipelines in general, they are simple execution logic, because these resources can interact with each other. They can have dependencies on each other. Part of the configuration of one resource probably needs to be known before something is built on top of it. Think about a network configuration which needs to be known before you can deploy anything into a network. And then obviously that configuration needs to be passed around. That's the reason why a graph-based backend is superior in those cases. It has the right inherent execution logic, so it can work on that graph and take care of all of the dependencies without needing to encode that kind of logic into a linear execution logic that a pipeline would favor. Okay, so we have our configurations down here, right? Then we have our abstract request. which asks from the developer side for something. So now CI pushes that to the orchestrator, and the orchestrator is already configured here. So it knows what to do. This time the context is staging. And that leads to the fact that a resource graph for staging is created. Yeah, which probably looks a little bit like this. What happens now if this should happen again? And now it gets interesting. If I want to add a Redis cache on top, I now just add 2 lines of code into my score file as a developer. Ready type Redis. The orchestrator already knows how to actually summon a cache of type Redis in staging. This one over here. Great, so it is used. And what happens is that in reality, this Redis node is created as part of not only of the resource graph, but also in reality it is being created and cared for. And the interesting thing is that because this happens with every deployment, now the lifecycle question comes out of the equation, right? Because the rhythm of business for the orchestrator is the deployment. So every deployment gives you an opportunity to mutate not only the requirements of the developer from the infrastructure side that he wants for his application, but also from the infrastructure engineering side to say, okay, I'm evolving my world. Yeah, now Redis caches are built in a different way because there was a security incident. And you could also ask the orchestrator questions like, hey, who on my runtime estate is actually depending on this kind of resource definition? And now that I changed the infrastructure as code under it, please go ahead and redeploy all of those who are depending on this resource definition. So I get my security patch out into the open in the least amount of time possible. Cool. What else does the orchestrator do for you? It manages the progression between environments. And that is the missing piece, so to speak. How do I get from dev to staging to prod? And how do I do that with the appropriate amount of logic in between? Yeah. Usually you have two parties which are concerned, the orchestrator and third-party systems. So it all starts with a git push from the developer. Yeah. And in the end, it hopefully ends with a correctly running deployment. So, but what happens? There's a resource graph built. App and infra configs are generated. Policy checks are triggered, which means probably that an external policy agent like the SNCC one or open policy agent is triggered into action. Yeah? We're waiting on the response, and then we're continuing the flow. We are triggering a human sign-off. That could happen in the orchestrator or in a third-party system as well. In this case, we are notifying a third-party portal to execute a sign-off because the UI there is nicer and what the people who are responsible are used to use. Okay, now that we have received a sign-off, we're deploying to staging. And then we trigger a success. That means we move a Jira ticket forward, we notify a Teams channel, and we upgrade the status in the Backstage portal, which is running in the background. And then we build the resource graph for production, and you get the idea. It all continues from there. Right? And this kind of sophisticated logic is usually happening in a backend. And is usually happening as part of a golden path or quite some golden paths that you build into your platform. So how are golden paths driving the automation and standardization goals? I have a few examples quickly. If I need to have any kind of resource for an existing workload, it's just 2 lines of code. If I need to spin up a new environment as a developer, I just git push. Yeah. If that means a new environment needs to be created, the orchestrator will take care. If I need to upgrade all of my Postgres instances from v14 to v15, I update the central definition and then let the orchestrator take care of the rollout. If I understand the difference between the deployment A and B and what actually makes the problem, I probably want to quickly roll back if I have a problem in production. With the orchestrator, that's a simple click because every deployment, as you have seen, is a complete graph, is a complete discrete deployment set. that can be redeployed at your wish. And if a user deploys to dev, run integration tests, run sign-offs, checks, compliance, and then promotes to staging, well, probably everybody is happy. Okay, so I hope that you have, in theory, an idea now why it makes a lot of sense to not only have a platform backend, how that platform backend should look like from its capabilities, and how that exactly pans out for Humanitec's Orchestrator. That leaves me with only one thing to say. We have a very straightforward process to get you from an intro to us over a straightforward process and into your running platform. But hey, the shop is not open today. Go to humanitec.com. Talk to somebody from sales. I'm probably pitching a bit today. I can't do anything else with the topic, right? But I'm not selling. You have to request that on your own. Wow, already a lot of time is gone, but I still have time for a quick demo. Let's see how that pans out. And as every good developer, I'm starting on the terminal. Okay, so now obviously the microphone is right in front of my view of the keyboard. Let's see how that pays out. I've changed into my reference architecture number 35 by just changing into the directory. I'm using a tool called denv to set all of the development context from here. Hopefully nothing can go wrong anymore. And this is actually an instance of the reference architecture you've seen before. And it is the one that also brings along Backstage. So I can go to the Backstage portal here to get myself a starting point quickly. I'm going to use the pod info service template and get myself JTest 101 as a starting point created. So let's now to create an ECR repository. It's going to create a GitHub repo. It's going to create all of the things that are needed to actually kick off the development of a new project or product. So I have my score YAML here. If I go in there, I can see, as in every good demo, there's a variable hello with the content world. The image is being set by the pipeline. I don't need to set it here. And I'm asking for a DNS record because I still hate typing IP addresses, but nothing more. Okay, so let's take a look at how that looks on the orchestrator side. So my JTest 101 application has been created here as well, and I have a development environment which is currently already being deployed. So how is that happening? Well, if I go back here, I can take a look at my .github directory, and in there is a deploy YAML. And this is a pipeline. So on every commit to GitHub, this pipeline will get triggered, and in the end, it will run score Humanitec, which will translate the platform agnostic score specification into the dialect that the orchestrator understands, and execute -- deploy, and by that deploy into the development environment. And it is up and running already. That means if I go in here, take a look at the route, and copy and paste myself this completely unmemorizable domain, I can show you that pod info is up and running. So that wasn't hard, right? Nobody would have thought that that could go wrong. But this is like the easy part, right? Start right, everybody can do. Yeah, every system out there has scaffolding capabilities, can take a template and create a new skeleton for you. But how to go from here in a way that is controllable and sensible, right? Let's see. As a developer, I first of all want to do one thing. I want to have more environments, right? So I'm creating a new environment. I'm cloning from my development environment because everything is good there. I want to have a staging environment, and I'm going to call it staging. Right? It has a draft because I cloned from development, and now I can literally say from dev. And now this is being pushed through the pipeline. There is no bespoke pipeline in place. This is the standard one, which is just creating a deployment set and deploying it to the environment staging. So nothing really interesting happening here, apart from the fact that it was really easy to create my staging environment, right? Yeah, because all of these environments have nothing special to them from the orchestrator's viewpoint. They are just different by context. And as I have specified how to create the corresponding resources by context, it is very easy for the orchestrator to materialize this out of thin air. Okay, if I go in here, I can see, okay, my workload is becoming healthy in time. Yeah, but the deployment succeeded already. Great. In development, I can take a look. Yeah, everything is here as expected. And obviously, I could now go ahead and say, okay, I want to have a prod environment as well. That is not more complicated than the last one. So let's take a look at how I can now push something new through here. And I'm going to use the edit button here. And I'm going to use my own example by asking for ready the Redis. And I'm going to try to be my work self, and I'm going to be in best practices, right? I'm going to create a new branch for this commit. So I'm creating a pull request. Great. So this is checking for ability to merge automatically. Now we're inside of GitHub. It's always a little bit tricky. The UI doesn't catch up so quickly there. And WebSockets and my home network, that's a different story as well. So well, it's probably going to take a little bit of time. Yeah. Now this is taking longer than usual. GitHub, don't fail me. Okay. Okay, so quite some things are actually seeing degraded performance currently. Thank you, GitHub. Okay. I mean, I can now hobble around and we can together wait a lot of time, or I can just take a side step. I'm probably going to take a side step. Okay. Let's do something else. Okay. Quickly going. Oh, I sometimes use that name. Okay, so let's go here. Okay, I have my score YAML here. And now I can just edit this locally. Say ready, type Redis. So this is literally not how it's meant to be, right? But let's see. What we're going to do now is we're going to use humctl score deploy. And we're deploying to the app jtest 101. We're deploying to the development. And we're going to deploy to the org HTC demo 35. Does it say? Haha. Yes, of course. That makes a lot of sense because I've said that here. And just so you know where that is coming from, or is GitHub having fun already in the background? Would be much more nicer if that was progressing. No, it isn't. So let's take a quick look here. And you can see the container is actually this one here. And what we absolutely need to do now, of course, is we're not having a pipeline who's going to set that for us. We need to put this in here as well. Of course. Okay, it says pipeline run status. This is cute. Awesome. CTL score deploy. And if I now look in here, I can see that I have ready the Redis. This is coming from resource definition called Redis in cluster. So sorry that that did take a little bit longer than expected because of GitHub throwing degraded performance in my way. I hope you enjoyed the show nevertheless, and I'm not going to now really progress this deployment to production because that would just be two more Humanitec score deploy commands where I just change the environment to what I want to deploy to. But this is all really artificial, right? We're not using the pipelines as they would be specified in GitHub to actually promote the stuff and do the work. This would be artificial. So I'm going to drop that out. It probably gives us a little bit more time for Q&A later on. Later on is good. So I would say I'm finished with my run through. I hope you enjoyed the show, and I will take a minute or two to quickly get rid of this microphone in front of me and switch to my usual headset, because that makes it a lot more easy for me to actually interact with you guys in Q&A mode, because I tend to work with my hands a lot more than I usually do when I do these demo situations, right? And I don't want to be bashing my microphone all of the time. So give me a minute to switch to my headset, and I'll be there for Q&A. Thank you very much, and see you soon.